Okay. Uh, so today should be the last day that we work on this classroom block. Today is the last day that we'll be working on the classroom block that we've been doing this one. So let me just do a quick recap. I'll share my screen. I'll share the entire screen, and then we can go through together. So mm, at first we started out with no, not that. At first we started out with a single story. Ish, cut the meeting. Before she starts. Is this the one? I don't think this is the one. Accidentally cut. Ah, sorry guys, I accidentally closed the window. It should be okay. So before I close the window, I was trying to share this sample drawing that we got from the architect. So this is the way that it was. Let me just share my screen. Kindly confirm either by sending a message or just confirming that you can see the screen so that we can take a look at it together.
I can see it.
Okay. So as you can see, the total length here they are estimated for 1, 2, 3, 4, 5, 6 classrooms on the ground floor, and then later on they propose that they have more rooms on top, meaning they might have about 12 classrooms in total. Okay. So this is the architecture drawing. The architect had designed for about 65.9, almost 66 meters long, and then 12.2 meters wide, just for including the corridor. But minus the corridor, the classrooms would be like 8.6. The internal diameter, the internal length. So this is actually a good drawing. And yesterday we talked about the how concrete is cast, because when you're the way that you design, it's different from the way that the contractor will execute the works. Design is usually theoretical. Construction is extremely practical. You have a lot of challenges on site. Sometimes maybe the concrete supplier may not be able to supply the concrete. Sometimes you might not have the finances to do the whole thing. So here, when they designed for it to be about 66 meters long, Mundia yesterday we talked about those joints. Yeah, joints. like construction joints, expansion joints, what. So for about 65 meters, yes, 66, you are very likely to have construction joints, because when you think of it, according to our design, we are designed for, so this is 66 times 12.2 times 0.12. We are designed for 120 millimeters a thickness. So we're talking about 96, approximately 100 cubic meters. So we're saying 100 cubic meters. If we divide by, maybe if each truck will have 10, so we're talking about 10. And if you're spending about 30 minutes or even an hour, 60 minutes on each, so we've got about 600 divided by what? 60 divided by 60 to give us 10 hours. So now imagine having to cast concrete for 10 hours. So obviously there'll be stops, there'll be what you need to carry out some quality control, you need to sample some cubes. So you are very likely to have construction joints in here. Or when you finish this slab, you need to cut certain sections. It's called a saw cut joint. Let's see if I've got, I think I might have an image of a saw cut joint here from one of, I think it's this one. Let me pull it. So a saw cut joint, you just cut the surface to control the cracks. If you've been on a basketball court before, in fact, let me see if I can pull up. Okay. So I'll show you an example of a saw cut joint, and then I'll also do a Google search so that you just know that when you're casting concrete like that, it's very, yeah. So here, right here, this small image, they are saying 5 millimeter wide by 15 deep crack induced joint. So this one is a so-called joint, and then this guy went further down. Ideally, you do not want to go down because then you have moisture, and if you put a barrier here, like maybe a polythene sheet here, then maybe moisture can be prevented, but you do not want it to reach down because anything can seep. It could be termites, they can start finding their way up. Could be moisture or underground water. The water table rises, so you do not want it to go completely down. You want it to just reduce, and the purpose is so that you can control those cracks in the, yeah, in the one code joints too. So for example, crack control joints in foundation slabs. Here we are calling them contraction, but for me I know them as socket. Let's see the image here. Something like that. So I did all this, but this is what I meant. They create something like triangle or triangles. How to what? Okay, but let's see. Let me go here and say what are socket joints in construction. Here, control joints in concrete. Socket joints are used to create control joints in concrete, which help control where cracking occurs due to shrinkage. The cut should be made at a predetermined spacing and only after the concrete has obtained sufficient strength. So you cast concrete, you wait for it to have sufficient strength, and then now you can cut. Let's see if they've got any. No, you don't cut across. You cut along. You cut in the X direction, like this. You see here it shows that socket joint. So the assumption is that if it's just one whole thing, it's very likely to crack. So to prevent some of those cracks, you induce so this one is very good. You see that they do not go down completely, and then you can use something like this. So if you've got time, guys, you can review that one. So there the crack will be there, but it will be controlled there. So this and this to me is a very good illustration, and also this one. Okay, so much. So and then previously the client wanted to have this drawing as a single story, or this structure as a single story, like that. But then they proposed that in more for future. So the assumption is that they do not have the money right now, but they can forego the beams and then just put the columns and the roof. So that once they find funding, they can come and cast the slab, and then they'll have more classrooms. So that's how we started with that structure. Let me open my portal. Where is it? That's how we started with that structure. We did stub columns. We did those. Were they 553 beams and 250? Were they 250 something? So this is my 3D. So this one for me, I actually even changed it to concrete beams. But let me just save. So for me, I've moved from those steel, the UCs, the universal columns. I've done it in concrete to compare in terms of cost. Will the steel be cheaper or will the concrete be cheaper? And then when you think of concrete, you're not just thinking about the concrete itself, you're thinking about the formwork, you're thinking about the labor, you're also thinking about the time. So let me open that other one, the one with steel. What is it? I think it's this one. Oh, okay. Okay. So we have this one that has steel and then it's got some concrete. We started by creating grid lines on the ground floor. Just go. We created those grid lines and then what else did we do? We created the stubs themselves, and then after the stubs we added the levels using the building set out, and then we did the roof and the slabs, the first floor slab and the ground floor slab, and then we did an analysis using. So here you've got the building set out, very important too. You use the edit story to check your populated floors, and then concrete members. There we used some concrete columns for the stubs, and then we went to the steel tab. We used steel columns, steel beams, and then we performed an analysis using some preset tools. For this project, this one I think is the one that gave us those errors. But when we did the check, everything was okay. But then when we tried to run it, it gave us that error. Let's see if it will still give us that error. I think this is because they were placed on the eaves. But if we put them on each floor, I don't think we can have that problem. Yeah, so this one is the one that was giving us that problem. And then what else did we do? We went to Prota Steel. See if we can be able to go to Prota Steel. So as we were doing that in Prota, I was also doing it in Revit. So for Revit, you can create some connections and then you can import them. For example, in that other video, we failed to put the eaves, but we placed the base plates. So, do you guys have any questions before I start doing this in Revit? According to the Prota models that you did, do you have any questions? Okay, if there are no questions, then let me show you how to create the connections in Revit, and then if you like, you can put them on your in your AutoCAD. So for me, let me show you what I did. I need this. I need For me, I actually even placed them on the on title blocks. I even added some connections. So for me, the final thing looks like this. It looks like this is how you when you finish detailing, it should look for presentation or for submission. If you need to submit it to your client or you need to submit it to the council, you need to put it on A1 sheets. So for me, you can see I even added this strip footing that is 6 by 2. For example, from here to there, it shows it 600, but then it uses this foundation was at 200, which is 200 is 8 inch. Yeah. So I placed this and this, and you can see I also added these sockets. You can see there. So what you can do is you can just create very small text and say, when you place it like that, you say socket joint. And if you like, you can use those dimensions. Since it's a 120 slab, you can just say maybe 50 millimeters deep. SOG. SOG means slab on grade. Oh, maybe just by 10. Obi was asking the thickness, which is actually a good thing. Someone supposed to be 10. Okay. Yeah. So when you do that, you won't be able to see, but you can. Uh, there it is. I just copied the existing and then I'll extend it. Extend it on this side so that I can just have it as one thing. Also, I would like for it to be bold, just so it can stick out. And maybe I can change the color, maybe I give it something like a yellow. And then I'll rotate it, and then I'll paste it everywhere where I'd like to show that this area needs a socket. It needs a socket join. Somewhere there, and then I'll go. Actually, I'll move it. I'll move from there, put it here, and then I'll copy this. I'll have my auto on so that I can move at 90 degrees. Another there, another one there, another one there. That would be it. So now when you do your little editing, if you like, in there you can create that hatch pattern that shows that this is concrete. You make your text big for identification. You put it on a sheet. It should look something like this. So this is my foundation with all the dimensions. It shows me the F meaning footing. My size is 17 and the depth is 400, and so on and so forth. When you try to print it there like this, when you preview, it should look like this. And it shows socket joint 50, what. It shows you're using a 120 C30 RC reinforced concrete slab. with conforce 257. Okay. So this is you can name it what you like, but for me I say structural floor plan with the foundation and ground floor layouts like that. And then what else did I do? I cleaned up the. You observe that it will give you these. Okay, so also the slab reinforcement for the first floor, it shows my 10. We're using T10s or Y10s. The bar mark is 19, being spaced at 250. If you wish to quantify the quantity of steel here, it gives you a shade. Prota gives you a shade. It shows you use a total of 5,984 for the first floor slab, which is 5.9 or 6 tons. And then it gives you how you're going to cut them. Here it shows you it's a size number 10. Bar mark is 2, BM is 2. So for example, the one that I was looking at is, yeah, even this one is a bar mark. You can see that it anchors into this beam when you cast concrete. Although this is a steel beam, when you cast concrete, it will have some anchorage. So it shows. Also, it shows you the cut length. You need to cut it at 850, and then 600 will be for this, 210 will be for that. So Prota does that. What else? It gives the total. It shows the reinforcement. It gives the unit weight. Unit weight of steel is what? This square over 162. So where this 0.616 is coming from is because our D is diameter 10. So 10 by 10, you divide by 162 times the length. This is usually supplied in, what is it, 12? But the unit weight will be this. It's 0.617. This is 0.617. And then if the calculated length is that, you multiply times 9695.4, and it shows you this number. It shows you the total. This length is an accumulation of these lengths here. When you add them up, it should give you this. And then here, this should be my, what level was this? Where this were? This is the canopy. It just shows me the section, gives me the name, but it doesn't give me the elevation. And then this is the wall plate or the eave. It shows me how they are sitting, the arrangement. And then here, this is the roof, although this is not a very good drawing. It shows me the elevation of the beams. So here it's 8.2, and then we were given the offsets, you remember. Also here is 8.2, but the level itself is at 9.8, the apex. So in the middle here, it's going to about 9.8. And what that means is, if you've been doing in Revit, you've been doing it in Revit also, when you go to the south elevation there, it shows you this 9.5 plus at 200 or 300, 9.8. And then here, it gives you section views. You remember how we were asked to draw these sections in concrete design. So it shows you there are eight Y16, and the bar mark is 2. It also gives you the dimension of the stub. It also shows you the stirrup or the link, depending on what you call it. And then it's also got some clips. So here the clip there, the clip there. It gives you the cut length like that. And then here it just modifies. It shows the same thing that it was showing there. And then it gives you the shade here, the column concrete shade. The only thing is that also here it shows you the stubs. It shows you that it's going from 0, from whatever your natural ground your 0 is. It goes 1.3 plus that 400 here for the thickness. It's 1.7. 1.7, that's according to also, what was that? The level, wasn't it? For example, if you open your Prota, when you go to building setout, building edit story, here it gives you that 1.3 that we are seeing. it said minus 1.3, right? Plus the 400 for the footing, 1.7. So this is where that elevation, the column elevation, that's where it's coming from. When you open it, here it is the math. It shows you, and then it also shows you that you are creating a step of 200 to just prevent water ingress. This will be your ground floor, meaning if you've got extreme conditions of water here, at least this curtain will be able to ensure that water is not entering the room, as opposed to if the slab was just here. So it gives you information. It also gives you the reinforcement for these stab columns, and then the footing also gives you. So if you're an engineer who also does some quantifying or takeoff, you just use these numbers. You can tell your client how much. And then for me personally, I also create details just to help guide. So this is the strip footing. I'm using 6 inch. It's a typical detail I show. And then I also throw in the contours. Although I actually didn't show, let me try to, you can use a head. We do that, we remove, you can say 257 uh, contours. Why? In brackets, you can say it's a wire mesh. And 257 just means it's the gauge. You know, Americans like using gauges instead of just using kg. And then you can copy like that, and it becomes seen. Shows you. If you like, you can move it even further here. You point it. So this is the typical detail for my strip footing. And then this detail is for the connection of the beam, the 203, the one that's sitting on the roof. Let's see. If I go like this, let's see, if I close this, if I highlight this, oh, this is a truss. So the other one you just choose, you didn't choose a truss, you used columns. Yeah, okay. How about if I was to open the concrete one? I hope you guys are following. Let's see, this one, if I hover over it, it says 203.133.30, right? So also this one, 203.133.30. But then, do you remember here I needed to show what kind of a column? Do you remember what kind of a column we used? The column that we used, the UCS. Yeah. Do you remember the size? It was, if I'm not mistaken, 254.254.167, right? So you go back here, you can show that information. You can add the multi-line. You say it's a UC, and it's a 254 by 254 by 0.87 kg. 254.254.137. Let me just confirm. Yeah, 254.254.167, not 137. So I'll copy this. I know it's somewhere here. There it is. 167. I'll change. I'll say 167, and then I'll put it. I'll rotate it to have it sit perpendicular like that, and then I'll move it into my column field here. And then I've got a small detail. I show these boats, shows that this is going to sit here. This is a horn that will start from the beam, and then it's supporting there. And this is something hopefully I'll show you in Revit. Yeah. So that's the connection. I show the boats are 8.8 grade, the diameters are 16, and so on and so forth. And then this is the haunch between the 203 and the 203, and these are, and then this is the roof truss according to this roof truss. So that this is it. sitting on 257, 257, 67, 257, 257. And then that side, that's how you connect. This is the connection method. I also show the anchor bolts how they'll sit. Three of them will be sitting on a 400 column, and what will be sitting there is a 257, 257, 67. And then this is a section for the hole. What else? Like that. And then this is just a typical step. This is an opening for a ring beam or a lintel. And then this is a lintel ring beam section like that. So that all of that will look like that. You look like this. You have your foundation and ground floor, and then you can have your slab with these columns that will hold the slab. Then you can have these columns for the which one is it? These in the section these. Oh, yeah, these two. This one and this one is these two like that. This is where the roof is meeting. And then this other one, this is now the roof. This needs more information. It needs to look like this one here in port. For example, if I was to go to the wall plate, change to plan view, it should look like this, showing the purlin. This one doesn't show purlin, so it's not a very good drawing. So it needs to be changed. And then we've got the section, that information, the canopy columns again, and then 300 shows the column elevations for the concrete, but we do not have column elevations for the beams. So how you get the column elevations for the beams, you need to go into Prota Structure. Maybe that's something that we can discuss later at a different time. And then we've got the footing schedule, and then now these details, these connection details. You can say connection details and foundation details like that. They can be typical. And then if you like, you can add the 3D, some pictures, so that when you print, it looks really good and the contractor can be able to understand. So that's the presentation. If you would like connection details, like I said, you can use Prota or you can use Revit. In Revit, if you'd like to create this punch like the one that we had in this drawing, oh, I'll go to the model space here. Something like this one, where you need to go is you go to steel and then you go to connection here. So here it asks you, this is info. Okay. Here connection, it will ask you, or you can load your connection. When you click on that little pop-up, this connection details will come, and they are quite a lot. If you do not know this, the specific ones that you want, you can select them all. Then once taken all. Okay. So here, structure connection settings, connections, parameters. You can run them. You can check if they've been approved. So what I want is the apex function. It's not here. So like I was saying, you can either go one by one if you know them, or you can select them all, then you add them that side and you okay. And then they'll be inside, they've been loaded now. So how you connect is you press this the beam that you want to connect, the element, and you control a plus. There it comes. You add and then you go to steel and then you say connection and then it gives this 2 and 1. So here how Revit interprets this is that there's a connection, but it's now for you to tell it what connection you want to give. So while it's highlighted here, it shows generic connection. On the drop down, it will give you all those connections that we have loaded. Now it's up to you to choose. So for me, I want an apex hunch. I'll click like that, and it comes. You give it some time, you check if it's in fine. Okay, there it is. So as you can see, this is slightly similar, if not exactly like this. Although the way where we are looking at it from is 3D. If we look at it from a section, if we can create a section, this section is this one. I was in 3D, then we go to my maybe first floor level, and which beam is this? Just the first one, the beginning. So I'll create a section here so that you go there on section, you press like that, make sure it's at 90 degrees, okay, and then when you click the bubble here like that, it shows you this stick figure. But you want more than a stick figure, right? You adjust the limits or the extents. You do not want to see everything. And then if you like, you can change the scale here. Maybe you can say 1 to 50. Most connections are given in 1 to 50. And then you change here to fine, and then it comes there. You see it. So this and this pretty close. Although this one just shows those to my lines as connection detail as bots. But here it shows as holes. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So you've got 1, 2, 3, 4 lines. 1, 2, 3, 4. But you're on both sides, so a total of 8. Let's see here it's got 1, 2, 3, 4 also. And it's also got some welds. These are welds. This is how you interpret welds in engineering drawings. So if you like, you can create a call out detail. You go to annotate. Let's see if you tag it, does it say? No, it doesn't. So you can create, I hope I haven't forgotten how to create a call out detail. Invitation here should come. No, just a revision clause. How do I analyze? Yeah, there's view. I think it's here. This is a call out on create. When you do this, and then when you double click, it takes you to this detail. Now you click in fine, and then you can either choose wireframe or the hidden line like that, and then you can make it bigger 1 to 25. And then now this view, if you like, you can take it in AutoCAD, or if you like, you can work on it right here. And then you can name these. How you name them? I think you go to this and take you tag. You give it a tag like that. I don't know that information is given. How about when you click, you go to the tag by category. You see there, it gives the information. What kind of a beam. Except for this, there is no tool. It also shows you it's in the mid. So how you can now convert it, you take it in. So now you're just beautifying now. You've run the analysis and the analysis is okay. So now you're just trying to create this to my details. So yeah. And then you can export this. You export it as a DWG like that. Call out detail, what. All these are presets you say next. You choose your location. For me, I've been working on my desktop. You guys can hear me? Okay. I've been working in my desktop there. I'll take it in teaching material. I can call it, what can I call it as? I'll give it, okay, let me create a new folder. I'll say connection details, and then the name, I can say hunch, apex function. connection detail. DWG select. If you wanted a GXF, you can select. For me, I want DWG. I okay it. So now I've got a DWG file in my folder where I've been saving everything. Without a doubt, I go to my here connection detail. I have it there. What I can do is, you see, it comes. So now I want to take it to where I've already been working there with the other information. I just, yeah, highlight everything, right click, clipboard. I'll say copy with base point. I'll choose this part as my base point, and then I'll go to where I've been working in, and then I can put it here to blend in with the other information. I'll paste, click on clipboard, paste, and then I'll put it there. But as you can see, it's quite small. You can scale it. You can either scale it according to factors, proper factors, where you multiply by either 50 or 20. Okay, so let me show you. Or you can use Crook's method, where you just enlarge it. So when you click on this thing that says scale, you can click a point. Here it says, the command says scale, specify base point. So this will be my base point. And then it asks you for a scale factor. So for me, if I say, if you remember, if I say 25, see how it becomes big. It becomes really big. I'll undo, Control Z. That's too big for me. 25 is too big. Let me try 50. Base point, scale factor 50. Now it's even bigger, right? Before was 25. So maybe 10. Base point, scale factor 10, smaller. So you can be doing all that, all that, all that, all that. Alternatively, you can just click like that, and then now you eyeball. You tell where it will be good. So for me, I can judge that, okay, here it will be good, and then I'll move it. I do not want it to get intruded with the other drawing. I'll put it there, but I didn't select everything. So I'll click that and that, and then I'll move it like that, and it can be there. And then if it's too much, I can either click this, make sure my auto is on, take it up. Also this, I can bring it down. I'll select that, select move. When you hover, it gives you a center. Now you can bring it there. And then if you'd like to match properties, you can match. There, I can tell the bubble is hidden. I move this there, and then when I go here to my detail, connection details, I can see that it's there. Although it's got a lot of colors, since I'm printing in my monochrome, when I go to print preview, there I can see that one. And then the contractor will be happy with the work. You can also label, if you like, you can label these bots, and so on and so forth. So let me save, Control S. So that's the haunch. And then if you'd like to create this other end detail, remember, you select that, you control, you select that, then you go to connection here, still connection, it creates a connection there. Now it's up to you to tell Revit what kind of a connection. You can either use this knee, or you can use this other one, or we can try to look for something far much smaller. Yeah, although I don't think we'll be able to find one that has one. Yeah, okay, this one does have one. Even this one, but this one looks better. It looks as if it's got a base plate. Take some time, but there we have. You see, it shows like that. We can do the same. We can create that call out detail. We'll go to our section view. We'll create that call out detail. We went in that view, and then here on create, create call out detail. There we click, it takes us. Not showing that information, meaning it's not in fine, it's in medium. When you change to fine, it shows that information. Yeah, and then now you can move this, that it's out of the way, and then you repeat the process of exporting what we did. And then here also you can create, you like that, you go in still, you create a connection, detail, there's a connection. You tell Revit we are using a new. Tell Revit we are using a new. Although this one is different. This one looks very ugly. Let's see. This one is new frame bolted with punch. It's the same one. New frame and base plate. And then plate. Is it similar? You can change, you check. It's this one. Yeah. There. Very easy. It even creates a cap for you there to close up the column. So now you got this connection, got this connection, got this connection. How about this one? Here you just use an input. You click, even this one if you go ahead. And then you go to steel, connection, connection. Now we've got three. I don't know. I don't know if we've got any three. This is for purling here, you search. No. Vertical purling, double brace, no. Anything with beams, no brackets. Eh, anyway, you can, like I said, you won't just wake up knowing. I think we should have used the tool. You won't just wake up knowing these connections. You have to read drawings, perform some research. Like none is just it's not something that you're born with. It takes a lot of practice. You see moment input, connection moment. So maybe between these they should be let me try to use the moment input, but that's too small. So you can change this plate. Don't think this is it. You can modify. There you go to customize it, or you go to the properties, edit type. Is this the one? There was one that allows you to actually I remember when I read it there. You can make this very big, the plates. Oh, that's a lesson for a different day, but you get the concept. Let's see. You edit it into bigger. Yeah, 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 modify parameters. So you edit, and then it will give you the base plate. You make it extremely big. We are using my is it 533? Yeah, here. This is where you can change the plate layout, plate thickness. Maybe you want to use 16. Bolts and holes, you can give it maybe by bolts. Clearance is 0. How about the plate itself? And here you can check. If you do not want this view, you can change to plan view. Maybe you say front, back, front, and that it shows you. This is a better view. This is the size of our beam, and we want the plate to be really big. Yes, I mean make it big. Here it's giving you the edge distance. 6 and 7, 6 and 7. How about if you say maybe 200? Also here 200. See how it's increasing. So maybe here I'll give it 100, and then here I'll give it maybe like 400, like 150, and then here I'll give it something like 600. Too much. So maybe 400, 400, 550, 500. This is approximate. And then the bolts also, you can increase them. You can add more bolts and holes here. The diameter, the type, in inches. Vertical boats, how many do your number of boats per side? Here it says one. You can say five. Now we want them one. Not in that direction. Vertical boats. Give them names. Group. Yeah, so guys, you will play around with it essentially until you get it right. And then you can also change it to Revit. You apply, and then you have that bigger plate. That's the way that it usually works. And then for last but not least, I hope it doesn't disconnect. How many minutes? 6 o'clock, what about 12? 15 minutes. Okay. So here we can create a base plate. It had given us a, well, it had given me a challenge in Prota Steel. But let's see, Revit will be extremely easy. Oh, I want to change the, maybe give it wireframe so that it's easy for hidden line. And then you say, you click that, control, you click the stub, you go to your steel connection. This is basically just an end plate here, it's already here, base plate. And it comes, selects. You can change the type of hooks that you want, whether you want gel hooks, according to edit parameters function here. If you'd like to see this in 3D, you change the view there in 3D, like that. And also the boats are too close to the beam, right? So anchors, number, two, fours, anchor boats, says normal. For me, I like, you can use maybe the gel hooks if they have them. Let's see. Or maybe the fisher one. Oh, J, this is the one that I was talking about. The J anchor. And then you shift them, you give them a clearance from, how about if I go from front? They are too close there. Plate corners, base with dimensions. How about the angle parallel? What? Yeah, so you do your thing. You play with the numbers until you get it right. And then when you're done, you can create a detail, then put it in there. So for example, my section view here, section 2, I'll go to the bottom there, and then I'll go to view, I'll create a call out detail there, and then double click it. I'll say fine. If I would like to, I can put this in transparency. This, when you go there, graphic display options, you can make it extremely transparent. Maybe you give it like a 7. You see, now you can see them. Previously you couldn't see them, but after giving it a transparency you can see them. And then you can export it and put it, move like that and move. Okay, so that's it for presentation, that's it for Revit. I don't know what, if there are other things that you guys, hmm? You can use Prota also, but Prota requires some work. Let's see. Let's see. If load Prota still. Yeah, personally, because I've been using Revit for a while, so I find it far much easier. But if you just want to be using Prota for concrete and steel, then I would advise you do a lot of research on steel. Concrete is very easy. Steel will give you a challenge. Because yesterday I remember the apex hunch being just somewhere here, but I couldn't find it, and I spent a lot of time on it. And this is the gel hook that we've used. Yeah, also maybe because this is a trash, when you select that also. Uh, which one? You select that and select that, and then maybe you want this use option because it's supposed to be instantaneous. Once you just do that, oh, okay. So the selection method you start with there, because there it was telling me when I click, it says select beam. I'll select my beam here. Select use beam. Select that. So there you select that. Select beam. This one. Select first use beam. This one. So proceed. But should be. So guys, if you've got any questions right now, please ask before the class finishes.
I've got a question, Mr.
Okay, go ahead.
Okay, so before running the analysis,
In Prota.
don't we have to first
Load.
design the before running the analysis? Don't you have first to design the connections, or how does Prota determine if the structure is stable without the analysis or without the connections? How does it determine if the structure is stable?
Okay, so that's a very good question. Paul is asking, and how does Prota determine the connection? What type of connection will be used if you do not define them when analyzing? So the answer to that is that for Prota, those connections for it, it's not these connection details. It's just supports. It works on either it's a fixed support or a roller or a cantilever support. So now for it, it will just those are the primary. For example, when you go here in Prot, when you go to 3D, when I click on this column, I right click it. Here there's an option for defining the supports. The load here, update column ends connections. So for it, that's all it requires. The connection detail will have to be by yourself. So here there's no hinges, both ends hinge there, hinge at the top, what. But if you place hinges, then it becomes dynamic, right? Then it will be sliding. But there's one thing that guys that use those original softwares use. I saw someone use what was it? In Protosteel they call it I think it was like an interactive thing. I'm yet to see if I can get it. What it does is that you just highlight like that. Oh, I'm in command. When you highlight the drawing like that, you just right click and then it comes somewhere here at the bottom. And then when you click on it, it would create those connections for you. And also you can check if there's a class check. So all of these points that you're seeing is supposed to be a connection. So hopefully that answers your question, Paul.
Yes, yes, it does. Thank you.
Okay. Any other question, guys? When it cuts, it will be the end. Got about a minute or so. And like Mundia said, he will show concrete. Concrete doesn't require a lot of connection details, no. Oh, you need to number them. Number them. Here, the number. Perform numbering. Apply and start numbering. When the numbering is completed, you close and then you go to create either a full or part drawing. How much time are we remaining with? If it cuts, you get the other information on the videos. Hmm? Don't want it. Okay, guys. This when it cuts, it cuts. Other information you find it on the in the video. So last time that I used column elevations was when I was doing some shop drawings, some fabrication drawings, and then it produced. Anyway, they are different. So we'll see. Maybe Mundia tomorrow will come in. That one was cut. The video was cut. But let's see. How do my boots here? Ah. So now you can go to the drawings manager, and it's giving you these. When you double click it like that, export or create drawing, open drawing. Where is it? It's here. Aha. So you see what it did. You saw what it did. Now it's created this. So let me try to go to an elevation. Double click. Okay, let me just select all of them. Select all of them. Now say open drawings. And now you have those elevations. See, it's adding them here. This, adding them there. See this side? These are the cut lengths for the steel. And it's giving those schedules. Remember there were the schedules in for the steel, for the rebar. These are the schedules. We use S355. This is the cut length, the net length. The name, the name, let's doing it secret. I'm going to put S355. But when you check like that, it's like a problem. For this one, it gives the name, the 254. Then it gives the click, the road, etc. So on, so on, so on. You click on that other one, more information here. S355, S355, the UK, the 533, the dollar. Nothing. We didn't create any, but for the problems we did, if you had created them, you'd be seeing something like, if you look at this one, this is the angle for the truss. Yeah, but you need to refine it also. Yeah. So that's that. Thank you so much. Bye bye.